Okay, people, quick look here at question 1 from 2020. Now look, there's always a few of these that are like common sense, and one or two that might be related to the special topic for whatever year. So there's 13 questions. And you need to answer 10. So I think in terms of exam strategy, you know, I definitely answer 10 anyway if possible, and you could leave time and come back and do a few spare ones afterwards, or 11. Now it says give brief answers, so we don't want to do the dog on it, but sometimes the diagram still is worth any amount of writing. So let's go, let's get it done. Okay, so question A there. They're asking about traffic speed. Monitoring signs are used. Identify one environmentally friendly energy source suitable for the speed monitoring unit. Now it says identify, so solar panels. Identify. So that's it really. That'll do. Now B. So we talk about reading the question. Okay, so B there says explain the process of quality control in manufacturing technology. So QC, the process of quality control. Okay, so it's to make sure that parts are not faulty or defective. So what you can do there is, like, you can test them by, you could do X-ray testing and ultrasonic. So they're all non-destructive. Can be done. Now you can also do destructive, but by sampling though, maybe one in maybe 1,000 could be checked. And the last thing there is you can have tolerances. So you can say that, like, measurements can be plus or minus, like maybe 0.3 millimeters or something. So if you said, like, you know, that has to be like 200 millimeters plus or minus 0.3. So tolerances can be used. So that's quality control anyway, to make sure that stuff isn't faulty. I might just zoom that in a small bit more there, guys. Okay, so C there, they asked about Mary Anderson. Okay, so she invented the wipers, windscreen. Apparently she was travelling on the bus over in America somewhere, and she saw the driver trying to stick his arm out the window and clean the windscreen with a rag or whatever, and she designed a wiper that could be operated from inside, and she took out a patent on it. So discuss, so it says discuss the contribution to the windscreen wiper. So to discuss it there, so Would I write that down? I think I would, but I'm not going to do it here now. But that's what she did anyway, and she so she patented it. So, which means that when everyone else used that idea, then she made lots of money. Now, Christopher Cockrell. Invented the first hovercraft. I think also called an aerofoil. I think it is anyway. And third one there is John Philip Holland. Was, I think, the son of a Clareman, or his ancestors came from Clare, and he designed a submarine for the US Navy. Okay, so that there, we don't want to do the dog on the answers here now, but just to read the question carefully so that we do what we're asked to do at the same time. Now, D. So, modern wheelchairs are developed to help improve the mobility of users. So there's a photograph there with that, just showing an electric wheelchair. So describe the function of casters on the motorized wheelchair below. Now look, the casters there, you'd know them from shopping trolleys and stuff like that there. So I'll just draw in. So your caster wheel there is able to swivel around. So, you know, everybody would be familiar with caster wheels. But, so, what we were asked to do there is describe the function of casters on the motorized wheelchair shown. Now, they are to provide support, because you're going to be looking at the photograph. There's two wheels that work independently there, and the casters then, they provide stability. So it doesn't capsize or flip over. And so that's one thing, and they also are easy to steer or maneuver, because they can swing around. That's why they're used in trolleys and warehouses and stuff there, because there's great maneuverability in them, like. So that's what they do there. Now, E. Okay, so the wheel rim is 350 millimeters, and then it's plus or minus 0.2. Now, I was talking earlier on there about quality control. They have tolerances. So the tolerances. Okay, now that's a way of, when you're manufacturing stuff, the more accurate it has to be, the more expensive and slow it is. So if you say I need it 350 millimeters exactly, that's very expensive to make. But if you say like plus or minus 0.2 millimeters, then you can be a bit off and it's okay. So the tolerance allows the makers to be a bit off. Now the reason for that is due to tool wear. Okay, because there's stuff involved there, like if you're using a cutting tool on the lead, it gets worn after a couple of hours or whatever, and all of a sudden it might be a 0.01 of a mil off and then 0.2 of a mil off or whatever. So if this can be plus or minus 0.2 of a millimeter, so the maximum is 350.2 and the minimum is 349.8. so the tolerance is the max minus the minimum, so that's going to come out as 0.4, so that would be like 8 from 12 and the rest of it cancels out. So your tolerance is 0.4 millimeters. So now F. Describe with the aid of a diagram the process of magnetic separation. Okay, so magnetic separation, you would have a pulley belt here, a pulley belt there. I will put in the pulley belt in a different color if I can find a different color. Okay. So here's our pulley belt. Just show it going around there now. Now it's good to use a few colors and brighten the whole thing up. Not good to do it all in just pencil or pen or whatever there. It looks a bit boring. Now, to show this properly, you're better off if you can, in a different color maybe, I might use green or something here. If you draw a magnet inside in this, like this here, okay, so that's our magnet inside the drum, and the drums are spinning in this direction. So I'm going to just put underneath this here now, straight under this here, I'm going to put a collector here, and this collects the rubble or the earth and rock and rubble in this skip. So what happens is all of the ore gets loaded onto this, and there's a mixture of magnetic. Now you could, if you really want to, use two colors here, so all the ore gets loaded on there, and I didn't do the greatest job now with this. I might just extend over my magnet a tiny bit further there. No. Okay, so I'll just bring that over here. And what happens is the magnetic ore, then if I use a different color for that, maybe orange, it'll stand out. So there's the magnetic ore. So the magnetic ore stays stuck onto the thing, and it comes over, stays attracted to the belt until it comes past the magnet, and it fills up this this skip here, or collector here. Okay, so I'm going to just remove that abomination of a thing there and put my magnetic ore over that. Was you okay? So basically, anyway, quick explanation of that there. So magnetic separation, okay, so a magnet inside the right drum keeps the magnetic ore stuck to the belt for longer, so it falls into a different, I'll call it box or skip. Okay, so again there, that's in the green thing there is the magnet. I'll just label that there. So here's the magnet, is the green thing there. So a good diagram is all you need there really. It just shows, and this is the earth and rock and stuff and that. Now, G. So the difference between amorphous, now amorphous means no pattern, and crystalline, which has a pattern. Okay, now there's two ways to explain this. You could explain it using metals, where those are atoms. Oh no, I have them the wrong way around now, so I'll fix that. So crystalline has a pattern, so I'm just going to draw in lines of atoms. And over here on this side, I'll just put in random atoms. Okay, so that would be in a metal. Now in polymers, I know I'm going to be taking up a bit of space here now, but in plastics it's like this. It's like this. You'd have long chains of polymers that have a kind of a pattern there. That's cross-linking, and no, I'm definitely brain dead. Definitely brain dead. I have that done again. So the crystalline has a structure, some kind of a rough pattern, and the amorphous, which has no pattern, I'll have the bloody Tipex all used up now. Okay, so this is more like spaghetti. So they're polymer chains, like spaghetti, when it's cooked, that is. Okay, so it's like spaghetti when it's cooked. So yeah, and they have a kind of a pattern. Okay, so that is G. Not my finest question. Now H. So suggest a polymer material suitable for the manufacture of football nets and two properties of this material. Okay, well, nylon would be the obvious one, because nylon rope and nylon string they're used for tying bales and stuff like that. So nylon could be used. Okay, so it has good strength, because nylon is very, very strong, and weather resistance. Okay, so it's not going to rot quickly from being out in the rain and stuff like that, and it's light. It's no harm to throw in an extra one, and it can be coloured. Okay, so that's a few there on nylon. So they're the properties of it there then. So I'll just, so it said identify as nylon. So that would be 1 is good strength, 2 weather resistance, 3 it's light, 4 can be coloured. So just to make sure there that they know what you're talking about. Now identify one polymer additive that could extend the lifespan of the net. Okay, so the polymer additive. Now you could add a thing called a UV stabilizer. Okay, now to resist it's kind of rotting, called environmental degradation. Now, when plastics are left out for a long time, let's say, I don't know if you ever found a plastic bag thrown on the ground or in a ditch, and they kind of crumble away into powder, and often that's as a result not so much of the weather but of the light, sunshine and stuff like that. So if you add a UV stabilizer, it resists the sunlight and the ultraviolet rays in the sunlight from breaking up the polymer chains. So yeah, so a UV stabilizer will do that. Now our next question there then is, I'll just scroll down here, J2 properties of bronze. No, 2 properties of bronze that make it suitable for propellers. Now the main reason bronze is used is for corrosion resistance to salt water. Now that's a huge one, because the salt water and the salt air is very corrosive to our steel. So like if you were doing a deck close to the sea now, you need to use, like, not steel screws, you need to use brass screws anywhere close to the sea. So, and it's the same in the waters even more so. Now 2 properties, so another one, so I'm going to say 1 is that it's corrosion resistance, and 2 is it's good machinability. And I'm going to try in a few more. 3 is it's tough, and 4 it's easy to repair. Now they're usually 80% copper, and maybe the rest would be tin and aluminium and other stuff mixed in with it. Now key. So 2 benefits associated with the use of wearable technologies such as Fitbits. And so, okay, so I'm going to say Fitbits. Advantages. Okay, so 1 is motivation. Okay, So it counts your steps and your calories, etc. So if you go to the fridge 10 times and you are walking like maybe 40 or 50 steps every time, you can calculate how much weight you're putting on every time you go to the fridge on a winter's evening. So the motivation there anyway, to count your steps and calories. Now the second one there is it allows you join groups and social networks. So advantages, benefits, no, you can, I'll say 3 there is you can set targets, and you can have, alarms, reminders, etc. So yeah, lots there, but no, one thing I will say, not that they want this written down, is that there's no evidence that wearing Fitbits and all this stuff does any good whatsoever in terms of weight loss and all that. But anyway, you won't read that from the manufacturers. Now, so that was K. Now L. So 2 factors to be considered when selecting appropriate materials for electric powered Formula 1 or Formula E cars. So Formula E. Now look, there's really only one, well I guess it's 2 criteria that matter in Formula 1, and that is strength to weight. Now they're always talking about the strength to weight ratio. So describe 2 factors to be considered. So really 1 is strength and 2 is weight. And that is why carbon fiber is used in the body. I think something like 80%, and a lot of the rest there then would be aluminium, alloy. I'll change that to alloy in the engine, because the lighter the material, the better, once it's strong. Okay, so the 2 factors is the strength and the weight. Now M. Identify 2 materials suitable for manufacturing the body. 2 factors, 2 materials. I kind of, yikes, I kind of have that answered. So carbon fiber and aluminum. Okay, so I'm going to just change this, and I'm going to say that that was M answered as well. And that is it, I guess. So didn't put in an awful lot of diagrams into that there now, a few, but yeah, there we go.